At Oro 5:30 local time, a Russian Buyan M corvette, carrying 8 caliber cruise missiles in the Sea of Azov, was preparing to fire on Ukrainian cities. While the mission had been relatively quiet so far, everything was about to change in a matter of seconds. Unbeknownst to the Russian sailors, 7 Ukrainian drones were hunting them. The lead Ryback accelerated to 400 km/h as Russian checkpoint guns opened fire. Tracers filled the dawn sky. Each 23mm shell could turn a drone into scattered debris. The checkpoint gunner couldn't see the drones, but he could hear them. He fired at the sound, walking his rounds toward that distinctive whine of motors. The lead Ryback jerked hard left. Shells exploded around it, each one capable of instant destruction. The drone pushed to maximum speed, screaming past before the gun could follow. But the damage was done. Gunfire alerted every Russian position within 10 kilometers. Messages spread through telegram faster than military radios. The element of surprise was gone. The operator's screen suddenly filled with static power lines, invisible until the last second. The drone pulled up sharply, clearing 110,000 volts by just 2 meters. Every instrument went haywire compass, spinning wildly video feed, flickering, flying blind for 3 agonizing seconds. Then a radio tower emerged from the darkness. The operator banked hard left, missing the guy wires by inches. Behind the lead, Ryback 2 more followed 30 seconds apart, using the chaos to slip through. These were the spears designed to blind the ship's radar defenses. 4 Bober drones took the northern route slower at 200 km/h, but carrying heavier warheads. These were the hammers that would strike after the Rybacks cleared the path. But those telegram warnings had already reached the next checkpoint. A Repellent 1 jammer waited, flooding control frequencies with 400 watts of electromagnetic noise. The lead operator's screen went black, signal lost. But the Ukrainians had anticipated this. Pre-programmed waypoints kicked in. The drone switched to autonomous mode, navigating by accelerometer, and optical landmarks flying blind through the electromagnetic storm. 3 minutes later, the video feed returned. The Bober was exactly on course. But ahead, a BTR-82 blocked the highway, its machine gun already firing in predetermined patterns. The operator dove into an industrial zone, using buildings to break the line of sight. But those buildings sheltered Russian soldiers. Hearing drone motors, they poured out like an anthill kicked over. The drone held 10-meter altitude. At this height, Earth's curvature created radar shadows. A hilltop radar that could see 50 km at altitude could only see 12 km when skimming the ground. Physics became their shield from the BTR. The drones threaded invisible corridors of safety, while soldiers fired at sounds and glimpses. But statistics don't lie. Concentrated fire from a coordinated squad finally connected. The third Ryback spiraled into a parking lot. Its warhead detonated on impact. 2 Bobers and 2 Rybacks remained. They couldn't afford to lose anymore. Then the lead Ryback crested the final ridge. The operator's screen filled with something that shouldn't exist. The mission briefing had been catastrophically wrong. In 4 seconds, he'd have to make a decision that would either save the mission or destroy every drone. The Panzer launched 6 missiles simultaneously, but these weren't ordinary surface-to-air missiles. These were Panzer ME anti-drone interceptors developed after commercial quadcopters had humiliated Russian air defenses. Each missile weighed just 12 kg, but carried 200 tungsten spheres in a fragmentation warhead designed to create a donut-shaped kill zone. The spheres expanded outward at 1/800 mabriversims, creating a lethal cloud 10 mm in diameter, more than enough to shred drones. The Panzer operator launched missiles at staggered altitudes, forcing the drone to fly through at least one fragmentation pattern. The fire control system calculated intercept points, creating a three-dimensional box of death. Each missile's proximity fuse sent out radio pulses waiting to detect metal. But the Ryback's operator knew the system's critical weakness, a 1.2-second arming delay after launch. At 432 km/h, the drone covered 140 km in that time. The moment he saw the missile launch, he dove straight toward the Pantsir. The missiles streaked overhead, still unarmed, unable to detonate. By the time they armed, the Ryback was already below them, using the launcher's own safety protocols as a shield. The operator leveled out at 5 meters and lined up on the Podlet K1 radar, the system providing targeting data to every Russian launcher within 200 kilometers. The Pantsir's twin 30mm cannons opened fire, each barrel cycling at 5,000 rounds per minute. The gunner tried boxing tactics, but the fire control solution lagged by 3.5 seconds. The drone operator changed course every 2 seconds, ensuring the gunner was always solving an outdated problem. The Ryback punched through and slammed into the radar antenna. Its shaped charge detonated, creating the Monroe effect, blasting a hypersonic jet of copper through armor like paper. The jet tore through the antenna array, the processing units, the operator stations, and out the back wall. The second Ryback targeted the P-18 spoon rest early warning radar. The Pantsir switched to thermal imaging backup, but dawn created temperature inversion, producing false heat signatures. The drone's electric motors generated minimal heat, maybe 10 above ambient blending with the morning sea. It appeared as a cold spot, then disappeared over cooler land patches. The thermal tracker lost lock. The gunner fired in desperation, spraying 5,000 rounds in a spiral pattern. None hit. The Ryback struck the P-18 dead center, eliminating 200 kilometers radar coverage instantly. With both primary radars destroyed, the corvette offshore had lost its early warning network. Without the Podlet and P-18, the ship's radar could only see 40 kilometers, giving less than 2 minutes warning. The defensive shield protecting the corvette had vanished. The ship preparing to launch missiles at Ukraine was now blind and alone. The corvette's radar detected drones at 4 kilometers, ghost contacts that appeared and disappeared with each wave. The ship faced an impossible problem, distinguishing drones from sea waves. Doppler failed. Algorithms filtered out threats as false returns. Still, the ship fought back. The AK-630 M2 duet system spun up, spewing 10,000 rounds per minute. The computer used Kalman filters to predict drone paths, but the operators made random course changes every 2 seconds. The duet had been designed for large, predictable missiles, not nimble drones. It was like using a sledgehammer to hit a hummingbird. Firing solutions lagged. The corvette deployed PK-10 decoys, chaff flooding radars with hundreds of false targets. Against radar-guided missiles, it would work. Against drones guided by cameras, it was useless. The drones ignored the sparkles and closed in. The corvette's TK-25E electronic countermeasures activated, pumping 200 watts across the spectrum. Against ordinary drones, it would sever the link. But Ukrainian drones used frequency-hopping spread spectrum 128 channels per second. The jamming caused pixelation, but not disconnection. Video feed dropped to 480p, annoying but effective enough. The captain ordered evasive S-turns, but a 949-ton ship takes 15 seconds to turn 30 degrees. The drone needed just 50 milliseconds. The Ryback operator timed his run. At 500 meters, he switched to manual. The radar mast filled his screen. The duet cannons couldn't depress low enough. At 200 m range and 3 meter altitude, the drone was under their arc. Sailors fired PKMs, but they faced human limits. Eyes too slow, aim too late. They were literally firing at after images. The lead bober aimed straight at the radar mast, shaped charge primed. The captain screamed for emergency launch procedures, trying to fire the calibers before it was too late. But the launch sequence required 2 minutes. The bobers were only 30 seconds away. The first bober slammed into the mast. Every radar, communication suite, and data link on the ship went down instantly. No longer able to fire, they were sitting ducks. The second bober dove toward the corvette's port side, targeting the missile magazine behind 15 mm of steel. At 100 meter, the operator made his final adjustment, accounting for drift and list. The shaped charge had to hit at exactly 90 degrees for maximum penetration. He had practiced this hundreds of times, but reality included shaking hands, sea spray, and the knowledge of what failure meant. The bober struck the missile magazine's forward bulkhead. Its copper jet tore through the steel like tissue spraying molten metal across stored missiles. The blast ruptured hydraulic pumps, fuel lines, and electrical systems simultaneously. Hydraulic fluid ignited coolant lines, burst toxic fumes, filled compartments, and warhead interlocks disconnected. 8 Caliber missiles sat armed but useless. The corvette did not sink, but crawled into port 12 hours later, its superstructure blackened hull, torn open smoke still rising. Recovery would take at least 18 months if Russia could even source parts under sanctions. The 8 Caliber missiles meant for Ukrainian cities remained unfired. Ukrainian operators sitting in bunkers 300 kilometers away had knocked out a $500 million warship using parts bought off Alibaba. Bye for now.